So greetings everyone. So for this project, we created a library management system using a LinkedList. So before we go into the technical parts, let's first take a look at what our program actually does. As you can see, we have 3 files here, which is main, node, and linked list. So the other files will be explained by my other members, and the file I'm going to explain right now to you is this main.java. So if we look at this file, this basically tells of us or our program what actions to perform. You can see that it's telling our program to do the addBook, the display, the search, and everything else. So what happens here is that first we declare our doubly linked list here. So without this, there is no way that you'll be able to use what you coded in the other files. So after that, we manually add our data using this list.addBook. So instead of opting for user input, we input the data ourselves. As you can see in the comment here, we said manually adding the books instead of user input. So we added the 5 books, which is Pride and Prejudice, Moby Dick, The Catcher in the Rye, Little Woman, and Frankenstein. And this is just for spacing. So in here, you could also see that we called displayBook. So what this just basically does is that it displays this data that we input through addBook. And then we can see here that we also have a searchBook method. So after displaying, we use the searchBook method. So the way this works is that it prompts the user to search for a book. And then in this case, we prompted Moby Dick to be searched. So this method basically searches if there is a matching title. And if there is a matching title, it should return a found status. And if not, it should return a not found. So after that, we use deleteByID. So this specific number is what we use to uniquely identify our books for easier removal. So from the name itself, it removes a book through its ID by matching what the user will input on what they want to remove. So after deleting it, it should print out a display again. We call the same display method twice. So in this case, it will display the current list. So the first display, it displays the original data that we placed, and for here, this second display, it displays only the list that has already been altered. Then finally, and if you can see here, we call sortByPages, which arranges the remaining pages into ascending order. So the data that has been removed will not be counted, as this method was called after that book has been removed. And then here finally you could see that we once again displayed the books. It would show that our books has finally been displayed in that specific or in an ascending order. So if we describe the whole process in a simple way, our main Java is basically saying, let's add some books, let's see them, let's find one, let's remove one, and then let's organize what's left. So now, one important thing to remember that we are using a doubly linked list. So every node that has been placed here is connected to both node before it and the node after it. So to make this easier to understand, our presentation will also include an animation showing how the nodes shift and reconnect during operations, such as adding, deleting, and sorting. So this will allow us to visualize what is actually happening inside the linked list instead of just looking at the code. And the reason why we have 3 different classes, which I showed here earlier, is because each class has a specific responsibility. So as you can see here in this node class, this represents a single book which has an ID, a title, and a number of pages. And our linked list class handles how those books are connected, added, searched, deleted, and displayed, and sorted. And like I said, our class right now, which is main class, the one I'm explaining, is where we call these operations and determine the sequence of actions on our program on which method will perform first. So now that we know what our program does and how these three classes work together, let's start with the node class, which is basically the building block of our Adobe linked list.
So if we open our node.java, this is basically the blueprint for one book. We have book ID, title, and number of pages. Those are pretty straightforward. They're just the information we want our program to remember for each book. Then we have these two, previews and next. These are a little more important because we're not just storing books, we are connecting the two of them. For example, let's say we have 3 books. We can imagine them like this: book 1 to book 2, book 2 to book 3, and then reverse all over. The next reference lets us move forward. So book 1 can say, my next book is book 2. And previews let us go the other way. Book 2 can say, the book before me is book 1. That's basically what makes this a doubly linked list instead of a singly linked list. So whenever our program creates a new node, we're not just creating a container for book information, we're also creating something that can be connected to the other books.
Now, one thing you might notice here is that all of our variables are private. So our linked list class can just directly say, give me your title or change your page count. That's why we have these getters and setters. For example, if we want to know the title of the current book, we use getTitle. And if we want to change it, we use setTitle. And we have the same idea for the ID, number of pages, prev, and next. You'll notice that when we go to our LinkedList.java, we're constantly using methods. For example, we use current.getNext when we're moving through the list. So you can think of this method as the way the other classes communicate with a node. The node keeps information private, and the getters and setters keep the linked list controlled access to that information, or they give the linked list a controlled access to that information.
So okay, now we have our node, but obviously our program isn't just going to have a one book. So the next question is, who's going to manage all of these nodes? That's where our linked list class comes in. At the top, we have the 3 variables, the head, the tail, and the count. Head is basically where our list starts, tail is where our list ends, and count keeps the track of how many books we've added. What's nice about our code is that we're also using the count to automatically assign the book ID. So we don't have to say the main like, okay, this is the book 1, this is the book 2. The linked list handles that for us. Every time that we add a book, count increases by 1. That's why we look at our 5 books in That's why when you look at our 5 books in main, they automatically get IDs 1, 2, 3, 4, and 5.
So greetings everyone, and I'll be explaining the addBook method. Let's break it down what happens inside our addBook method. So first we have public void add block string title int number of pages. So this is our method for adding a book. So it receives 2 pieces of information, which are title, string title, and int number of pages. So next, we want to create a new node. So we want to add node, new node is equal to new node. Ayan. So this creates a empty node that will hold the information of our new book. So next naman is the count plus plus. So we want to increase our count. So this automatically increase the book ID by 1. So if the previous book had an ID of 1, so the next book will have an ID of 2, and so on and so forth. Then we want to put the book's information inside the node. So we have new node that set book ID count, new node that set title, and new node that set number of pages. Ayan. So the first line here is set book ID. This means this gives the node its book ID 1, 2, 3, 4, 5. So the second line is set title. So this stores the string title, which is the book title. So next naman is the new node that set num of pages. So this stores the number of pages. Ayan. So next, so this checks if our linked list is empty. So if head is null, it means there are no books yet. So if it is the first book, we are gonna do head equal to new node, tail equal to new node. So this node or the new node becomes both the head and the tail. So because it is currently the only book in our list. So if there are already books, the else parts runs here. Tail that set next, new node set previous, tail, and tail is equal to new node. So the first line here, tail that set next new node. So this connects the current last book to the new book. And next naman, we have new node that set previous tail. So this connects or points the new book back to the previous last book. So finally, we have tail is equal to new node. So this updates the tail. So for example, mamumove siya sa dulo. Mamumove siya sa last new node. So making the new book the last book in the list. Ayun. So ganon. And lastly, we have system.out.println book added successfully plus title. So this line of code will run if the book has added successfully plus it prints the title of the book.
Now after adding our 5 books, we obviously want to see if they're actually there. That's when the displayBooks comes in. The program starts at head, and then we have our current variable. Think of current as our finger moving through the books. It starts at first book, we print that book's information, and then we do current equals current that get next. So our finger moves to the next book. We print again, move again, and then continue doing that until current becomes null. That's why when we run our program, our first output shows all 5 books in order we added them. So we don't need to manually print each book. The loop simply follows the connection that we created when we added the nodes.
Now let's look at the next thing our main class asks the program to do. It says list search book Moby Dick. So return our linked list to go find this book for us. So in our method, the search book and then the parameters string title. Method searches the linked list for a book based on its title. First, if head is equals to null, checks if the list is empty. If it is, the program displays a message and uses return to stop the method. Then node current equals head starts the search from the first node. The while and then in the condition current does not equal to null, loop checks each book one by one, while current.getTitle dot equals title compares the current book's title with the title being searched. If a match is found, the book's details are displayed and return ends the search. If there is no match, current.equals current.getNext moves to the next node. Once the entire list has been checked without finding the book, the program displays not found message.
Greetings, Sir Janus, and good afternoon. I am John Vincent in Miraples, and I'm going to report my part, which is the deleteByID. So here we can see that in line 54, the method public void name by deleteByID int id. What's that for? The parameter means int id is for the main method wherein it was typed like this deleteByID, then parentheses 2. So we do have if else here. Yeah, you see through, yeah, here. So if head is equals to null, meaning that this is empty, there is no element need to be deleted. So return because it's always been void. And if head is equals to tail, that means that head and tail is just the same single node. That means head and tail is in a single node, and it will check if head.getBookID is equals to ID. If 2, then 2 is equals, right? Then it will delete, and head will be turned into null because there's no need to be pointed anymore, and will be a and there will be indicator, and we will return that because there is always a void. And for the second if, check first value. If head.getBookID is equals to ID, it will delete the head, but the head will be pointed to the get next, meaning the head is equals to get that next head, and the previous of it will be pointed to null as always, meaning the 2 will be the head now. So let's proceed that and return. Then check the last value. Check this last value, which is 5, and our tail will be point into 4, and it will be pointed to null because as always it will be returned, and there's always the iterate for the whole process, which is the 2 3 4, and this while loop is for checking the current is not equals to null, and current is equals to current that get next, and if not found, this equals to null. It will print a book ID not found. It will also return. So for the relink, we will be proceeding in sysout, deleting the book ID. And here's the part of the confusing part. But let's say that the current is equals to 2, and the head is 1, and the tail is 5. So current.set next, which is let's set the next to the current.get next, which is the 3. So the pointer will be here, head to 3, and current.get next, let's set prev, it will be pointed to the previous of current, which is the head. So that's the whole point of doubly linked list. And here's we will see that the printed is 1 3 4 5. And yes, that's all. Thank you, sir.
After deleting book 2, which is Moby Dick, we now have 4 books left. Then, the main calls list sort by pages. This method is responsible for arranging the remaining books based on their number of pages in ascending orders. In this condition, if head is equal to null or head is equal to tail, then return, the program checks if the list is empty or if there's only one book. If either condition is true, there is nothing to sort, so the method simply stops. Since we have 4 books, the program continues. In this line, Boolean swap, we have the swap variables. This is used to keep track of whether any books were exchanged during the sorting process. In this line, the program starts a sorting pass at the beginning of each pass, which swap is set to false. Because we haven't made any changes yet, then the current starts at the head, which means the program begins checking from the first book. In this while, the program compares each book with a book immediately after it. For example, the first comparison is between Pride and Prejudice, which has 279 pages, and The Catcher in the Rye, which has 214 pages or 214 pages. In this line, the program checks if the current book has more pages than the next book. In our example, 279 is greater than 214 or 214, so these 2 books are in the wrong order, so they need to be swapped. In intemp, the program temporarily saves the current book's ID, title, and number of pages. This prevents the original information from being lost during the exchange. So, the program swaps the information between these 2 nodes, so The Catcher in the Rye with 2-1 form to 14 pages moves before the pride and prejudice with 279 pages. So in this line, swap equals true. Since the swap happened, swap is a set to true. This tells the program that the list still need to be checked again. So in
Last 2 minutes, anong status ng mga submissions nyo? Come back muna.
So current equals to current get next. After comparing the two books, the program moves to the next node and continues comparing the remaining books. So in this line of while swap, this part makes the program repeat the process as long as swap happened. Once the program goes through the entire list without making any swaps, swap remain false and the sorting process ends. So in the system out print, the program displays a message confirming that the books have been sorted in ascending order according to the numbers of pages. So this method works by comparing neighboring books and swapping in their information. Whenever the current book has more pages than the next one, it keeps repeating this process until the books are arranged from the lowest page count to the highest.
So if we trace the program from beginning to end, we can actually follow the output pretty easily. At the beginning, we add 5 books. Because our count method automatically assigns the IDs, the books become 1, Pride and Prejudice, 2, Moby Dick, 3, The Catcher in the Rye, 4, Little Women, 5, Frankenstein. When the displayBook method runs, we see all 5 because the program starts from the head and follows the next references. Then we search for Moby Dick, and the program finds it as book number 2. After that, deleteByID2 removes Moby Dick, since Moby Dick is identified as ID2. So when we display the list again, we're left with 4 books, as you can see here. Finally, we call sortByPages method. The remaining books are rearranged based on their page count from smallest to largest. So the final order becomes 1. Catcher in the Rye, since it only has 214 pages. Pride and Prejudice has 279 pages. Frankenstein has 280, and the book with the largest pages is Little Women, coming at 449 pages. And that's basically the whole journey of the data in our program. We start with the books being added as nodes. Those nodes become connected into a doubly linked list. We traverse that list to display and search. We reconnect the nodes when deleting, and then when we rearrange the information when sorting. So each class has its own purpose. Node gives us the structure of one book. Linked list manages how those books are connected and what can we do with them. And main tells the program what actions to perform. So rather than seeing our code as separate pieces, we can see it as one process where each class works together to manage our library. Thank you, everyone.